السلام عليكم ورحمة الله. دعونا نحل هذا السؤال مع بعض. We're still in calculus 1. Let f of x equals square root of 1 minus cosine x. What is the domain of f of x? The domain of the radical function is the radicand amount, the amount under the radical, this must be bigger than or equal 0. So number A, or question A, the domain is 1 minus cosine x bigger than or equal 0. So cosine x, if you make it subject, will be smaller than or equal to 1, just moving cosine here, negative cosine here. So the cosine x is, you know that the value of cosine, whatever the angle, always lies between 1 and negative 1 inclusive. So I'm sure that for every x, the value of the cosine will be smaller than or equal 1. So the domain here is R. So domain here is set of all real numbers, because, and this is correct for sine and cosine. Okay. What is the domain of f prime of x? So domain of f prime of x, let me write f of x again. F of x now is 1 minus cosine x power half, and the f prime by applying chain rule is half into 1 minus cosine x power negative half times the derivative of the amount inside the bracket. The derivative of cosine is a negative sign, so negative sign will be sine. Yes, so I can rewrite this one as sine x over 2 square root of 1 minus cosine x. Now the domain of f prime is, the domain here is 1 minus cosine x only bigger than 0, because this radical amount in the domain cannot be 0. So I remove now the equal here. So cosine x less than 1. Cosine x actually, as I told you, always less than 1 for every numbers, except, this is true, x belongs to R, except the values that make cosine x equals 1. And the cosine x is equal to 1 at the values of x equals cosine inverse of 1, which is 0 plus 2k pi. 0, the main angle, 0 degrees, plus complete number of periods. So the domain of f prime of x for every x belongs to R, except, or every x except x equals 2k pi, and k belongs to z. Okay, let's come back to our question again. This is the domain of f prime. Write the equation of the line normal to the curve at x equal pi over 2. First of all, we come to the derivative and define f prime of pi over 2. Okay, that's very easy and very simple to find. Always you have to find the slope of the tangent, then from it you can find the slope of normal. Okay, so this part, so just f prime of pi over 2. Okay, I can delete this one, no need. So sine pi over 2, which is 90, over 2 into 1 minus cosine pi over 2. What I'm solving now, I'm trying to find the slope of the tangent. Okay, so the answer is 1 over 2 times square root of 1 minus 0, which is half. So the slope of tangent is equal to half. So slope of normal perpendicular line is -2. Okay. I have the x is pi over 2. I have to find the other part of the function, of the point. Yes. So f of pi over 2, go to the original function and substitute to find the y coordinate of the point. So the f of pi over 2 is equal to square root of 1 minus cosine pi over 2. Cosine pi over 2 is 0, so square root of 1 is 1. So the point now, the point is 1 and, sorry, pi over 2 and 1. Pi over 2 and 1. And the slope of perpendicular m is -2. So the slope now of normal y minus y1 is equal to the slope -2 into x minus x1, which is pi over 2. This is the equation. Thank you. You can simply rewrite it and simplify it, no problem, to make y subject. Here, is Rolle's theorem applicable for f of x in the interval pi over 2 and 3 pi over 2? I think, yeah, Rolle's theorem applicable here because this function is continuous on the interval, in the closed interval pi over 2 and 3 pi over 2, and differentiable in the open interval pi over 2 and 3 pi over 2. And the most important point here, that f of pi over 2 is equal to f of 3 pi over 2, because the function, as you know, is cosine, and the cosine here, cosine and both pi over 2 and 3 pi over 2 is 0. So both of them is 1. So the answer of D, yes, Rolle's theorem applicable. Rolle's theorem applicable here because number 1, f is continuous on the interval pi over 2 and 3 pi over 2. And number 2, f is differentiable. I found the derivative here, differentiable on the open interval pi over 2 and 3 pi over 2. And number 3, third condition, that f of pi over 2 is equal to f of 3 pi over 2. Each of them is equal to 1. Thank you so much. See you next time. Goodbye.